Hello, everyone. Welcome again to another session of our Apache TinkerPop contributor cast. This time we are back again with our contributors. My name is Yang, and up here we have Cole and Kin. And today we're gonna be giving a post-release review of the 4.0.0 beta 2, the 3.8.1 and 3.7.6 releases that came out just in the last couple weeks. So now without further ado, let's get started. So some of our agenda today, we'll be going over some of the notable changes, especially breaking ones that happened in this last three releases. So we're going to be going over the 3.7.6 and 3.8.1 maintenance releases, and and also the second beta of our 4.0. And then closing, we will have a quick Q&A time. So for any questions, and we will try to give a sneak preview of what's coming in the 4GA. Now, let's go the 3.7.6 release. So one of the major notable thing is just that we add for Python, there's a set to list fallback. So basically traversal that returned a set of non-hashable items for Python, such as dictionary, set, or list. They previously caused a type error during the deserialization. So now what happens is that we're now returning them as lists, so cohorting them as lists instead, so that they no longer raise the error. So that is true for both graph binary and graphzone. However, if a set is needed, you would convert the list into the Python hashable item manually. So yeah, so that's just to take note. And there are some runtime upgrades we want to call out. So the in 3.7.6 now we are supporting node 22 and 24, as well as moving Go to 1.25. And I will pass it to Ken to talk about some of our performance improvements.
Thanks, Yang. So prior to 3.7.6 and 3.8.1, every time you open a transaction, the GLB has to open a brand new WebSocket connection. So that's like a full TCP handshake and WebSocket upgrade per transaction. And for short-lived ones, the connection setup can cost almost more than the actual work itself. So in 3.7.6 and 3.8.1, community contributor GitHub user Pratap Nara has added a setting called reuse connections for sessions. So when you set this to true on the cluster builder, the session will try to borrow from an existing connection pool rather than opening one of its own. I'll also note that if you're on the Gremlin server, you're going to want to pair this with closed session post graph op. That way sessions get cleaned up on the server right after commit or rollback. Otherwise, you might see some temporary session leaks until the timeout kicks in. If we can move to the next slide. So if you use this new reuse connections for sessions, in our test deployments, lightweight transactions went from around 3.6 transactions per second to 7.6. So that's almost a 2x improvement from just reducing that connection overhead. However, if you increase the number of sort of concurrent clients, that number goes down. Also, if you sort of, it's also latency dependent. So workloads that have more latency are going to see sort of a higher benefit. So another takeaway is just that the heavier transaction, so the more you do per transaction, and the lower the latency, the less it sort of matters, because at that point, traversals, the actual execution of traversal becomes the bottleneck. So just as a quick summary, for the common case of quick transactional writes, this is a pretty sort of meaningful win with just like a small builder flag change. Now I'll hand it off to Cole to talk about merge V, merge E.
Thanks, Ken. Just a small change I want to highlight with merge V and E. If you look at the example we've got on the slide here, the name property is getting matched in that merge pattern initially, and then it's getting overridden in the onCreate pattern. And this is something that's never been supported by the merge step. You're not allowed to overwrite properties from the merge map with onCreate. You are allowed to overwrite them with onMatch. But previously this validation was always done at runtime, and it was done when this onCreate option would get evaluated. So if you were running the step and it triggered the onMatch path instead, the validation would never take place, which allowed certain scenarios where you might have an invalid query and running it successfully for months, and then your data changes, you hit this onCreate path for the first time, and that's when you get the error. So that's just not a great behavior. So what's changed here is that there's now a compile time check for static maps here to validate that the properties aren't getting overridden. If you're passing in traversal-based dynamic maps for either the merge map or onCreate, that can't happen until runtime anyways, so that limitation's still there. But for the most common case here, users should get their errors surfaced earlier and not have the failure emerge at later dates. And now I just want to cover some changes that are exclusive to 3.8.1 here. First of which is some changes to Gremlin. So honestly, the example in the slide sort of explains everything I want to show here. The old Gremlin was arguably described as aggressively new line focused, where every step really liked to be on its own line. And with some of the new changes, it's a little bit smarter. It better mimics how humans would like to manually format their Gremlin. So yeah, you'll probably just notice the formatting just a little changed, a little more compressed, a bit more natural to read. Hopefully needs a bit less post-processing. And with that change to Gremlin, Gremlin has now been added to Gremlin MCP. So Gremlin MCP, it's still in alpha in 3.8.1. It's not generally available, but you can go download it from NPM if you want to try it out. And Gremlin is now baked right into it. So if you have Gremlin MCP installed, you can ask to format a Gremlin query, and instead of just feeding that through the LLM and have it try and figure out what to do, it's now going to utilize Gremlin and give you that consistent formatting you expect from Gremlin. That's a nice little feature. And final piece I wanted to touch on for 3.8 is we have a custom type writer in the graph binary serializer for Go. So custom types have always been a part of graph binary. Go has had a limitation where you can't write custom types. You've always been able to read custom types, but the writer's been missing, and Go is the only GLV with this limitation. All the other GLVs had abilities to read and write. So this just addresses it. You can see the example, just how you define and register custom type writers now. So this just creates parity with all of our other drivers, and this was contributed by Drino on GitHub. So Drino's now submitted a couple of PRs to give some serialization improvements in Go. So it's great to see. It's really appreciated. So thank you. And with that, I'll pass it back to Ken to talk about some of the 4 beta updates.
Thanks, Cole. So one of the major changes for Beta 2 is that all of the TinkerPop supported GLVs are now compatible with the 4.0 Gremlin server. So this wasn't really the case in Beta 1, as that one only had support for Java and Python. So in the next few slides, I'll probably just review some of the changes that were introduced in 4, starting with bytecode. We've sort of talked about this before, so I'll try to keep this as brief as possible, while still giving like a general overview of these things. So bytecode was allowed in every GLV to sort of represent a traversal in a universal way. So when you send this to the server would reconstruct the bytecode into actual traversals using the Java translator. The Java translator itself is pretty complex with lots of reflection and nested loops. So it worked, but it was really heavy. And then now with Gremlin Lang sort of reaching a sufficient level of maturity, we have sort of a second way of doing this. So any Gremlin string can be parsed into traversal using the ANTLER grammar. In 4.0, or GLVs will start sort of transporting these traversals using Gremlin Lang under the hood instead of bytecode. So a couple of quick reasons why. One is debuggability. So because it's a string, you can actually log it, send it, sort of read it, run it in a console. Just it's easier to work with because bytecode was most often just serialized as binary. And so it was just hard to work with. But another sort of deeper architectural win is that it kind of decouples the language evolution from its serialization versioning. And by that, I mean, today, if you're adding a new type to the request side, that's going to require a graph binary change, which is a major version of bump across the entire ecosystem because you need to know how to serialize that new bytecode. But with Gremlin Lang, because the request is just text, new types can just be added in minor releases. So it could be a big deal for the sort of pace of innovation moving forward on the request side, not on the return serialization though. But yeah, one other consequence of this is sort of that we're going to be promoting Gremlin Lang over Gremlin Groovy as the default script engine. Another side benefit of this is that it kind of closes some security surface of arbitrary Groovy execution. And another change that we made in 4 is that we're moving from WebSockets to HTTP. So one of the main reasons for this is just ecosystem fit. HTTP is sort of like the thing that everything else in the world kind of works on still. So like load balancers, API gateways, proxies, all that kind of stuff. WebSocket support and those layers are kind of limited or they need extra configuration. So just moving HTTP makes TinkerPop work better with your pretty much the rest of your stack with less effort. Another benefit is that it's just going to make things easier for sort of community contributed third-party clients. So making a HTTP client is much easier than making a WebSocket client. And just to touch on the HTTP endpoint itself, it's just a single endpoint / Gremlin still. And it's going to have the sort of same request format. One thing we should note about the HTTP support, though, in this beta version is that the implementation isn't fully optimized yet. So the clients, well, most of them will wait for the entire response before they start processing any of the results. So the WebSocket implementation had done that in chunks while streaming. So for large result sets, you might see higher latency compared to some of the 3.x GLVs. That's a bit of a known limitation, but it will definitely get solved before the official release. So with the move to HTTP, we sort of have a natural extension point now for customizing requests. We're calling these things interceptors. Just something, as I said, you can use to modify the outgoing HTTP request. So you can do things like adjust headers, change URI, attach metadata, whatever else you might need. It's particularly useful if you have a graph provider that has custom endpoints. So instead of sort of working around the GLV, you just plug in an interceptor, and that's going to sort of make everything happen transparently for you per request. So authentication is one of those things that kind of fits naturally in this model. So rather than having a dedicated sort of auth system baked into the protocol, like SASL was with WebSockets, in 4.0, authentication is kind of just like another interceptor. So for example, we have a basic auth that just adds an authorization header. So if your provider has its own sort of auth scheme, you should sort of implement your interceptor as a way to interact with it. Just as a reminder, one of the key shifts is like you now have a way to sort of control and see what happens to every single request before it gets sent to the server. One of the specific API for this, for the interceptors, is going to be slightly different per GLV. It's still a work in progress, but the concept is sort of the same in all of them. And yeah, as I mentioned earlier, .NET, Go, and JavaScript have now adopted these changes in beta 2. So yeah, all of the TinkerPop supported GLBs now have support for it. Yeah, so moving on to the transactions being re-enabled. So transactions are back in beta 2 after being disabled in beta 1. So just a quick note that these features are still sort of experimental and the spec is still being finalized, but we just want to get out in front so that we get some early feedback. So the model is slightly different from 3.x. So instead of building on top of sort of WebSocket sessions, transactions now are going to be identified by a server-generated transaction ID. What's going to happen is you call begin, the server is going to generate an ID, and every request that has that ID attached to it will be marked as part of the transaction. And obviously, we call commit or rollback to end the transaction. So in beta 2, only the Java GLB has supports for transactions right now. And the transaction ID handling that I was mentioning is going to be done mostly transparently. So if it can be used in two ways, like in that example, which is the sort of familiar g.tx.begin sort of traversal API pattern, or you can use the cluster directly and call the transact method, which will give you back a transaction object. Both work, and support for this should land in the other GLBs before the full release. Again, we're looking for feedback on this sort of new model, so please try it out and let us know what you think. And now I'll hand it back to Yang to talk about some .NET changes.
Thank you, Ken. Yeah, so diving a bit more into the GLVs that's been changed. So .NET is also one of the drivers that got changed to HTTP. Now it does not have the fully streaming capability yet, so one should be just keep in mind that that is a known limitation. Again, so the major difference, so most of the API remains unchanged. The major difference again is in the authentication and interceptors. So authentication was configured with the username and password on the Gremlin server constructor, and now for 4.0, you'd use the auth static methods via the interceptor parameters instead. So that is one of the major API changes. And another thing is that because of the move to HTTP, we removed a lot of the WebSocket related settings as well, connection pooling. So now connection pooling is actually now managed by the socket HTTP handler, which is part of the native library in .NET. And then so as such, some of the names for the classes are changed, and some of the settings itself are changed. So you can refer to our reference docs for the updates, and of course those are also being just worked and improved as we go into GA. So those settings may or may not change when 4.0 is fully released, just because we want to achieve that consistency across the GLVs. And yeah, so and along with that, so again with Go, the most notable change would be how auth is used within interceptor. So previously we had the auth info struct that is now removed. So starting 4.0, you would use for basic auth, you would use with the built-in basic auth with the interceptors, and then of course if you want to provide your own custom interceptor and auth mechanisms, you can do that through this. And again, there's also some new HTTP pool settings that's also is being passed along into the underlying HTTP library. And that I will hand it to Cole to talk about JavaScript.
All right, thanks, Yang. Couple of things to mention for JavaScript here. The first and most exciting in my books is that it's been rewritten into TypeScript. So we used to have our type declarations packaged separately in the definitely typed library. Now that's been rewritten in TypeScript, the type declarations are just natively included in our Gremlin package, which is fantastic to have. I'm excited to have that there out of the box. And this is all contributed by Tian is the GitHub user. So it was a massive PR for someone to jump in and take on that work of adding all the type annotations. So big thanks there. That's really appreciated. Other things to note here, just like Yan covered for .NET and Go, the auth is now done through these interceptors. You can see we've got an example here of constructing the basic auth interceptor and passing it in. Pretty straightforward how to use that. And one other note here is that all of our Antler translators, which were previously just written in Java, they've all been ported to JavaScript as well now. So these are all of our translators that convert from our canonical gremlin using the Antler grammar and can dump them out into any of our language variants. And the reason that's exciting actually ties into the next slide here, which is our MCP enhancements. And the first piece here is there's the new translation tool, which utilizes all these JavaScript ported translators. So you can now use the MCP to do the translation for you, instead of just having the LLM hallucinate something that vaguely fits the variant you're going for. It will now run right through our translators and give you reliable translations. You can target it to any of our standard language variants there, as well as Groovy, and there's an anonymized target as well. The anonymized target, if you have like a step such as has name Cole, it just strips out all the values in that, and it would turn it to like has string 0 string 1. So it's just used if you've got sensitive data and you need to share some example with an external party. You can just sort of strip out all of your data and give the structure of the query really easily. So yeah, it's great to have that just available through the MCP. Those translators all go in sort of one direction from canonical gremlin into the variants, but the MCP also has some extra hints built into it to help convert from other variants, such as like gremlin Python, into canonical gremlin, which it can then feed through to get the any targets. So use the translators directly, from canonical to a variant, but it can generally do any input to any output pretty successfully. The other piece with MCP that's changed here is the offline mode has been added. So previously you needed to have a Gremlin server available for the MCP, but now both translation and the Gremlin formatting we discussed earlier are available offline with no Gremlin server needed. They can just be run directly within the MCP. So yeah, those are both really exciting changes, and it's been great to see MCP developing along here. And then some other notable changes to cover. Neo4j Gremlin has been removed as this beta. So this was first deprecated in 3.7.0, and really the reasoning is that Neo4j hasn't supported the Gremlin translation library, which was necessary to make this work for quite some time. So the last version Neo4j that worked with this has been past end of life for a very long time. So it's been dropped here for the beta and for TinkerPop 4. Another piece to mention, SLF4j has been upgraded from 1.x to 2.x. So as you're doing your upgrade, you can check your login configs, make sure you follow the SLF4j upgrade docs to make sure you're converting properly there. We've added a new in operator for property access in Python. This is for elements, so your vertex and edge types in Python. You can now use the in operator to iterate through and search through property keys. So this just leads to a much more Pythonic way of accessing properties if you want to loop through them. The in operator really just gives you a cleaner, easier way to do that instead of the old method of just searching through a full list of properties. And last piece here, we've talked about this a few times in the past, but the Java-based process test suite is going away. So with this beta, that progression continues. So really our Gherkin-based feature tests, these are the standard set of tests to validate a Gremlin implementation. The process tests used to mirror it pretty effectively. At this point, the remaining process tests are only a handful of cases that can't easily be mapped into the feature tests. So if you're only testing with the process test right now, that's you're really missing out on the bulk of our coverage and validation. You really want to be adapting to the Gherkin feature tests. That'll be the main suite now and going forward. And yeah, that's all I wanted to cover here. So thanks again to all the contributors for all the great work they've done. If you want to see the full list of changes, take a look at our change logs as well as the upgrade docs. And now we'll wait for any questions. You got one here. What's the long-term plan for Groovy and TinkerPop? I can start that, and then Ken and can jump in if I miss anything. So Groovy plays a few different roles in TinkerPop. It's used in the server in two ways. It's used there's the Groovy script engine, which processes Gremlin scripts through Groovy. But then also a lot of the server initialization currently runs through Groovy. So when the server boots up, configuring the traversal sources usually runs through Groovy. And a lot of like preloading data is often done through Groovy and that sort of stuff. Any customization the provider wants to do often runs through Groovy. So in TinkerPop 4 in general, we've tried to move to the Gremlin Lang script engine, which is the grammar-based one, being the default script engine instead of Groovy. And you'll see, like with all the translator work, everything's sort of standardizing to that Antler grammar canonical Gremlin being the standard representation of Gremlin. So Groovy is sort of being left a bit behind on that, or at least it's no longer the focus. So that's one change. The other change is we don't want the server initialization to be reliant on Groovy anymore. So this is something that hasn't landed in the beta. There's an ongoing discuss thread on the dev list, and there's a PR up for removing Groovy from server initialization and getting that to be completely independent of Groovy as well. So if you have any thoughts or feedback, please take a look in the dev list and at the PRs there. We'd love to hear it. So ideally, the server should be able to run completely independently from Groovy by the full release of TinkerPop 4. The last place that Groovy really has prominence in TinkerPop is Gremlin Console, which for those that don't know is really built on top of Groovy Console. There's currently no plans of getting rid of that. Having Groovy in the console gives a lot of really nice abilities. So there's currently no intentions to get rid of that. But yeah, that's sort of the general plan for Groovy. It should take a much less prominent role in the server going forward. How do transactions work for scripts? Ken, do you want to jump on that?
Sure. I think this is probably about 4.0. So again, it's still a work in progress, but the current proposal is that the transactions are still going to be sort of the script base. So when I was mentioning the commit and the rollback before, so it's literal, like in the grammar, there's something that's called g.tx.commit and g.tx.rollback. It's the actual like script that will get submitted to the server, and the server will recognize those specific things from the grammar as triggering the start and the end of a transaction. So in the current proposal, it's those actual scripts that sort of start and end a transaction. It works either traversal based or script based in that way.
All right. As we see if there's any more questions coming, there's just a few other items I want to mention as coming up in TinkerPop 4. Some of these are still a work in progress, so may or may not land. There's still a lot of details to figure out. But one of them is there's been some ongoing discussions on introducing graph schema interfaces to TinkerPop, which is something that I've been really excited by, and had quite a bit of good discussion happening on the dev list there. So if that's a topic that interests you, please jump in. The thread's active right now. Would love to hear your thoughts. I'd really love to see standardized schema interfaces in TinkerPop 4. Hopefully we can make that happen.
And also join all the live discussions on our TinkerPop gathering every other Thursday.
Yeah, every other Thursday we've been having these live gatherings. Just get in touch on the dev list on Discord, and we can help you get the invite to those. Love to hear more inputs. Another item I want to mention as well. There's a recent dev list post from Stephen that he's taking on the match step rework, which we've got a proposal merged in quite a while ago. So the idea here is to have the match step start processing sort of a GQL style match sequences, which to me just gives a much more convenient and easy way of sort of seeding a traversal with simple to complex patterns, which I think can be more convenient in a lot of use cases. So we're really excited that that's making some progress, and I hope to see that land soon as well. So yeah, that's a bit of a sneak peek. That I don't think there's any other questions here. So thanks everyone for joining. Go try out the betas and love to hear any feedback.